Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll integrate those two problems in front of us. If you like my videos, please subscribe to my channel. It will help me keep on going, and if you like the video, I would really appreciate if you put a like in the comment. So let's start with the first integral, which is the integral of x square root of tan x divided by 2 sine x dx. Here I know there is a trigonometric identity that said sine of 2x is equal to sine x cosine x. But here I have sine x, I don't have sine 2x, so if I want to translate that trigonometric identity, sine x, it will be equal to sine x divided by 2 here and cosine x divided by 2. And the second formula that I will use, everybody knows it, tan of x divided by 2 is equal sine of x divided by 2 divided by cosine x divided by 2. Yeah? So let's use those in my in that integral. So my integral become square root integral of x square root of, instead of putting tan, I'm gonna put sine x divided by 2 divided by cosine x divided by 2, and instead of putting sine x, I will put 2 times 2 sine x divided by 2 cosine x divided by 2, and I have my dx here, and I have to put it like that. And those are the formula that I used here. Sorry. Those are the two formula that I used here. I use them in my integral. So now I know that I have cosine x divided by 2 in the numerator and in the denominator cosine x divided by 2, so I can simplify it. And my integral become integral of x square root of 2 sine square of x divided by 2 dx. But since square root of 2 is a constant, I can take it outside my integral, so it becomes square root of 2 integral of x. And I know square root of sine square of x divided by 2 is sine x divided by 2 dx. And here I can do integration by part. The formula of integration by part is u dv is equal uv minus integral of v du. And here I can take my u is equal to x. My u is equal to x, so my du is equal to dx. And I can take my dv is equal to sine x divided by 2. So my v is equal to the integral of sine x divided by 2 dx. I have a dx here. So I know the integral of sine is minus cosine, and because I have x divided by 2, it become minus cosine x divided by 2 divided by 1/2. Yeah, so it become minus 2 cosine x divided by 2. So this is my v is equal. So let's highlight them. I know my v is equal to this, and my dv is equal to that, my u is equal to this, and my du is equal to that. And let's apply the formula. Don't forget that I have a square root of 2 here that I need to add. So it becomes square root of 2. And now I have u times v, which is, my u is x, and my v is equal minus 2 cosine x divided by 2. That's my u times v, minus integral of v du. My v is equal minus 2 cosine x divided by u, and my du is equal to dx. And I can close my parentheses here. So I can write it square root of 2, square root of 2, and then I open my parentheses, minus 2x cosine x divided by 2, and here minus times minus is plus, and the 2 is a constant. I can take it outside my integral, become integral of cosine x divided by 2 dx, and I close my parentheses here. So I know that the integral of cosine x is sine x But because I have cosine x divided by 2, it will become sine x divided by 2 divided by 1/2. So it becomes square root of 2 minus 2 cosine x divided by 2 plus 2, sine x divided by 2 divided by 1/2. And there is a plus c here. Let's put it outside. And it becomes square root of 2 minus 2 cosine x divided by 2 plus 4 sine x divided by 2 plus c. Because like when I divide by 1/2, I have to multiply it, but I have to flip 1/2. It becomes times 2. 2 times 2 is equal to 4. So this is the solution of the first problem. Let's solve the second problem, which is integral of sine square root of x. So the second problem is integral of sine square root of x dx. Here I can say let t equal square root of x. So t is equal x to the power 1/2, and my dt become 1/2 x to the power minus 1/2. So my dt is equal 1/2 square root of x, because minus 1/2 it goes to the denominator and it becomes square root, and this is dx. There is a dx here and there is a dx here. So my integral become so my dx here, my dx is equal 2 square root of x dt. So now my integral become sine of t, because we said t is equal square root of x, and instead of dx I can write times 2 square root of x dx, times 2 square root of x dt, I mean. Yeah? Now 2 is a constant. I can take it outside my integral. So 2 integral of, but I know that square root of x is equal to t. So I can start with t sine of t dt. And here again I can do integration by part. The formula is u dv is equal uv minus integral of v du. And here I can take my u equal to t. So my du is equal to dt. And I can take my dv is equal sine of t dt. So my v would be equal minus cosine of t. So let's highlight. I took my u equal to t, my du equal to dt, and my dv is equal sine t dt. So my v equal minus cosine t. So let's not forget the 2 that is here. So I put the 2, I open the big parentheses. It is equal u times v, which is t times minus cosine of t, and then minus integral of v, which is minus cosine of t, and then my du is equal dt. So here I know minus times minus is equal to plus, so it become 2 minus t cosine of t plus integral of cosine of t dt, and I know the integral of cosine of t is equal to sine of t, so it become 2 minus t cosine of t plus sine of t plus c, and then I can replace my t first by u. It become 2 minus u cosine of u plus sine of u plus c, and then here we said actually, sorry, we said t is equal square root of u. Let's erase the last line, and then if we go here, we said t is equal to square root of x. So we replace t by square root of x. So it become 2 minus square root of x cosine of square root of x plus sine square root of x plus c. So again, if you like my video, please subscribe to my channel. That would help me. And if you like my video, I would appreciate a like. Thank you for listening.